We've just shown you a recursive algorithm. And you may be a little worried about it. You may be going, okay, but how does it know which values of the variables to use? Because I'm not seeing any explicit changes to those values. How does it make sure it really stops? Why doesn't it just keep unwinding? Didn't your high school geometry teacher never to use definitions where you defined a term in terms of itself? The good news is not to worry. And we've got a tool to help us understand that. Let's go back and simply look at a simple call to recurmul, recursive multiplication, using that set of environments to see how the computation flows. So here's my code. I've just got a copy of it here. And in particular, if I evaluate this, or load this, if you like, into a Python environment, a shell, we know what's going to happen, which is we're going to create a frame over here in which that name, recurmul, is bound to a procedure object. And it's got inside of it both the parameter list and the body, the set of things that it's supposed to do. Okay, let's see what would happen if we actually called it. So let's call it. Calling it says I'm going to evaluate this expression down here. And I'm going to first get the value of recurmul. I know what that is. It's given by that pointer there. It's a procedure object. And so I know that calling it says I'm going to create a new environment. It's going to inherit or have as a parent the same environment that the procedure has, the environment that was in place when we defined the procedure. So it's going to point to that frame. And inside of there, first I'm going to get the values of these two expressions, and I'm going to then bind the parameters of the procedure to those values. All right, I'm saying it in a long-winded way, but you've seen this before. We've now created a new environment in which A is bound to 2 and B is bound to 3. And relative to that environment, we're going to evaluate the body of this procedure. Okay, let's start evaluating the body. The body says, if B is B equal to 1? No, it isn't. It's 3, so it's going to go to the else clause. And the else clause says, I'm going to return a value. Great. I want to get a value back, and it says the value is going to be the value of A. Remember, I'm doing it relative to this frame here, so I know the value of A. It's 2. And I'm going to add to A the value of, a recursive call, another call to recurmul with different arguments. Now, think of this very straightforwardly. This is Python. This is an interpreter. That's an expression. It says to get the value of that expression, what do I need to do? I need to get the value of recurmul. Oh, that's it up here. Okay. I need to get the value of A. And remember, I'm doing it all with respect to this. And in fact, I should have done that better. To get the value of recurmul with respect to this environment, I'm going to go up and find it there since it's not bound down here. I need to get the value of A. There it is. And I need to get the value of B minus 1. Well, that's easy. There's B. I'm going to subtract 1 from it. And since recurmul is a procedure, what am I going to do? I'm going to create a new frame. Cool. That's exactly what I want. Because now I've got a computation that's taking place with respect to this frame. And how did I set that up? Well, I got the value of A. I got the value of B minus 1 from here. I've bound those in this procedure because that's what it tells me to do. And I'm now saying evaluate this procedure in this frame. Remember, when I get the value of this, I'm going to give it back to this frame to complete that addition. But I've now reduced this to simpler computation. And notice something else really nice. You may have been saying, well, how do I keep track of my iteration variable? It's not really iteration, it's recursion, but notice I've reduced B. And that's exactly what's going to happen. I'm going to keep unwinding this computation until I ground that out. Okay, and we're now in pretty good shape because what do we want to do? It says I need to get the value of this procedure, this body here, with respect to this environment. What do? Well, I say, is B in this environment equal to 1? No, it is not. So I'm going to return the value of A from this environment, which is right there, to, another procedure call. I'm doing another procedure call on recurmul. What do? From here, I get the value of recurmul. And I trace up that chain to say, there it is. It's that procedure. I need to get the value of A in this environment. That's easy. And I need to get B minus 1 in this environment. Well, that's easy as well. B here is 2. I subtract 1. And that leads naturally to yet another recursive call. Now, you're going to be glad I only did this with 2 and 3 and not 2 and 57. But you get the idea. I am now evaluating the body of this procedure with respect to this environment. And what do? I say, okay, is b equal to 1? Thank God, it is. But if b is equal to 1, what do? I return the value of a from this environment. So that computation gives me back a 2. But that's really nice, because what does that say? It says, gee, here's where I am. I'm now returning the value of a because I was in that recursive call. It says the value of this recursive call is 2. I'm going to give it back to the place that was waiting for it, which was up here. And what was I doing? I was waiting to get the recursive value. I want to add that to a. So the 2 is returned. It gets passed back up here. It gets added to that a. Those two pieces come to there. And what was that doing? That was saying, give me a return of those two values to the computation that was waiting here. And so, in fact, the 4 and the 2 get added together to give me 6. And what was that doing? It says, I'm now done because that procedure said return that value as the overall value, and that's going to get passed back up as the final value. Cool. A little slow in our computation, but really cool. And in particular, let's see what we can deduce from this. Each recursive call of a function creates its own environment with a local scoping of variables. So evaluating the body of the function in that environment is going to be very clear as to which value of a and b it's using, or any other variable that it's using. Secondly, the bindings for variables in each frame are distinct. And you saw that I had a different frame for each one of them. And those bindings are not changed when we're doing the recursive call. They are set up as we make the call. That is, I'm going to compute a new value of b, making it in this case b minus 1 in order to bind it in the frame. But I'm not changing bindings in other frames when I'm within one frame. I don't have access to them. And finally, we can see that the flow of control can naturally pass back to an earlier frame once the function call returns its value. So, finally, you can also see that inherently, this recursive call to a function, if done right, has the equivalent of reducing a state variable. We saw how each instance, each frame had a different value of b that got smaller and smaller until we got down to the base case. So we know that this is in fact going to ground out, is going to complete its computation, and that's great. So hopefully this gives you a better sense of how, in fact, the rules of evaluation allow a recursive thinking of a problem to create a very nice version of the code.